Hi, I'm doing a quick question on trigonometry. This is paper 2 of 2021 AS level. This paper is written in Namibia by the advanced level learners, subsidiary advanced level learners. So I'm looking at question 6 of this paper of 2021. So let's just go and get to that question to see how one can quickly solve that. Okay, so they say show that the equation, well, you have the sine of the compound angle x plus 60 degrees is equal to 2 cosine of x plus 30 degrees can be written in that form of this cube root of the square root of 3 or root 3 times sine x equals cosine x. Now, let us see. We have got sine of x plus 60 degrees is equal to 2 cosine of x plus 30 degrees. Now I hope you're familiar on how to expand this. So this is sine x cos 60 plus you have got sine of 60 and cosine of x. You can leave it like that. That equals to 2 times, I'm just going to distribute that 2 later. So this is cos of x cos of 30 degrees minus, it's very important you do understand that you're going to have a minus over here now, minus sine of x as well as sine of 60 degrees. Okay, we can perhaps distribute that. It's going to be 2 cos. In fact, I can just as well leave it out and just distribute it later. It's totally up to you. Now, you should be a little bit aware or familiar with your special angles, okay? And if you have a triangle here that is 90 degrees and that is 60 and that will be 30, this is going to be the 2 will be over here, 1 is over here, and that will be root 3. Okay. If you were to use your calculator and you want to calculate, say for example, the sine of 60 degrees, sine of 60 degrees, yeah, well, it's just going to be root 3 over 2. You can have a look with your calculator. Hopefully, if you have a problem with these special angles, and to expect you to be able to make sure the calculator is in degree mode. Okay, expect you to know this by now. Sine of 60 degrees is going to be root 3 over root 2. Okay, so on. So we find that from there, and I'm just going to complete that. So over here I've got sine x, but the cosine of 60 degrees, cosine is adjacent over hypotenuse. So 60 degrees, the cosine is 1 over 2 plus the sine of 60 degrees. I was saying sine of 60 degrees is root 3 over 2 multiplied by the cosine of x. And I happen to have 2 here. Then I have cos of x. And the cosine of 30 degrees, now cosine of 30, cosine is root 3 over 2. That is root 3 over 2. So obviously you're going to multiply that with that. Minus sine of x. And the sine of 60 degrees, again, as we said, the sine of 60 degrees, that is nothing but the sine of 60 degrees is root 3 over 2. I just have to come back to something over here. The cos of 30 degrees, cosine of 30, cosine is root 3 over 2. Okay. If you have to find the cosine of the sine of 30 degrees, where we sine of 30, we don't have sine of 30. I see where I made my little mistake here. This is supposed to be 30 degrees. I immediately picked it up. Okay, it's from that, so that should be sine of 30. That's why I was now wondering, why do I have the same ratio over there? Cosine of 30 is root 2 over 3. Good. But the sine of 30 degrees, yes, there we go. The sine of 30 degrees, sine is a half, 1 over 2. Okay. All right. Well, in this case here, one can distribute this 2 and that one cancel. And obviously also with that, if I was to carry it out, that's what's going to happen. I'm going to have here root 3 over 2 cos of x minus sine of x. On this side, I'm going to have a half sine of x plus root 3 over 2 cos of x. Okay, they want it in that side, so let's get all the sines to one side. So half sine of x plus sine of x is going to be root 3 over 2 cos of x. Okay, I just want to see, or do I have another, you're going to have this over here, sine of 60, the sine of 60 degrees is root 3 over 2. Okay, all right, so we have got another, if we're going to bring this one over, this is going to be the sine of 60 degrees times cos of x. The sine of 60 degrees, this we have to go back here, sine x cos 60, then plus sine cos x, sine 60, right, cos of 60 degrees, here we go, cosine of 60 degrees is a half. Good, that take care of that. The sine of 60 degrees is root 3 over 2 times the cos of that. Right, here we have, yes, here's the problem now. I have cancelled the 2's and I don't know why I'm rewriting it. Okay, can you see that? So let me just make sure that that coefficient is fine. Yeah, and here I'm just going to have cos x. Now that's going to be root 3 cos x. There we go. Root 3. I was now really wondering what is going on. Of course, we're going to subtract it by root 3 over 2 cos x. All right, it's no harm in you going back just to see if you are going to make a little bit, to avoid the errors. Okay, half plus the coefficients here, a half plus 1, that's 3 halves of sine x. And when you have root 3 minus root 3 over 2, okay, let me just grab the calculator to show you that one. So I have got root 3 minus, I'm just subtracting coefficients, right? Root 3 over 2, so that gives me root 3 over 2, so that is root 3 over 2 cos x. Now we need to get, once we have two things we compare and the denominators are the same, can you just as well also cancel them? So I have got 3 sine x equals to root 3 cos x. So cos x should be alone by virtue of how they want that. Okay, very important that you do understand that over there, right? So if that is the case, we're going to divide throughout by root 3. So this is going to be 3 divided by root 3 sine x is equal to cos x. Now you can definitely have a look at 3 divided by root 3 by rationalizing the denominators. You're going to have 3 root 3 over 3 if you do that, and eventually just going to have that. Okay, but I suggest you can perhaps use a calculator as well. So you can clean it up with your calculator. You can say, okay, what is 3 divided by root 3? And you will see the answer is just root 3. Okay, so this is then root 3 sine x, and that should equal to cos x. Now, I believe that is what we were required to prove, and we then did definitely arrive at that particular proof. Right, let's go to the B part. Now, say hence, which means we are supposed to use that. Say find the acute angle for which this is equal to that, or for which root 3 sine x is equal to cos x. So we're going to find the acute angle. That means that angle is an angle between 90 degrees and 0 degrees. That is an acute angle. We are going to find that angle x. Okay, everything is in degrees, so we're going to work with degrees. Right, so first of all, it's always nice if you can change these ratios to ratios that you know. Sine over cos becomes nothing but the tangent. So this is root 3 tan x is equal to 1. Same thing divided by the same thing over there. Then obviously you're going to have tan x is equal to 1 over root 3. Now I'm not going to rationalize the denominator. I'm just going to go straight up and say, okay, let me find what that angle is. Angle x, well, you can use a calculator. You will find that angle x is 30 degrees from special angles, but you can actually go ahead and punch that in to your calculator, the inverse tangent of 1 upon root 3, okay, which is just equal to 30 degrees. And that is the answer for that acute angle. Good. Right. You can always go back and then you can try the questions on your own and definitely see how I managed to solve them.